So, good afternoon, guys. Good afternoon. So, I welcome you guys to Chandu Biology Classes. So, in this session, we are going to concentrate on the chapter called Work, Energy and Power. So, this is for the IIT JAM people. Okay. So, in last class, we have discussed about certain part of work and energy, right? And in this class we will start doing the problems, and the remaining part we will complete it. Okay, so let's wait for 1 or 2 minutes and people are joining over here. If you have a rough note, you can take. No, take some book. Yes, started. Or get some paper from office. Pen will be there. Done. So last class path acha. Okay. So let's see some glance about what we have discussed in last class. Okay. So what we have discussed is work. Work is nothing but force into displacement, like F dot S. So the formula is Fs cos theta. Okay, and three conditions are there. If theta is less than if theta is less than 90, no, the work is positive. If theta is equals to 90, the work will be 0, and if theta is greater than 90, the work will be negative. These are the three conditions when I can say the work is positive, negative or 0. So I'll give an example over here. Let me take a circular path. And circular path in the sense I have taken a string and tied with some ball. Okay, now I have started rotating the ball. It will rotate in the circular path. So what is the work done by the circular path? Like I have applied force. So if I apply force only, it will start rotate. So what is the work done by the circular path now? Angle will be 90. So the force will be in this direction towards me, and the displacement for every point it will be tangential. So angle between them will be 90 degree. So work done will be 0. So since displacement is also happening but force also happening, the angle between them is 90. So work done will be 0. One more example. The pendulum clock is there, no? So it went to the extreme position and it started coming back to the same position. So tension will be towards upside, and this displacement is perpendicular to the tension. So here also the work done will be 0. So these are some example where I can say the work done is 0 since the force also applied and displacement also happened. Okay, and we'll see some questions over here now. Write the question. The force F is equals to 0.5x plus 10, 0.5x plus 10, 0.5x plus 10 plus 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 acts on a particle, F is equals to 0.5x plus 10, acts on a particle. Here F is in Newton and x is in meter. F is in Newton and x is in meter. Calculate the work done, calculate the work done, calculate the work done by the force during the displacement, by the force during the displacement on a particle from x is equals to 0 to x is equals to 2 meter, x is equals to 0 to x is equals to 2 meter. So, before that I will tell you the points here. So, work done for the constant force is Fs cos theta, or else I can say F dot S. So, work done for the variable forces integral F dot dx, this is from x1 to x2. So, this is one type of work and this second type I can find the work, and the third one is area under the graph like force and displacement will give the work done. So, these are the three types of question they can ask. So, what is the formula I can use over here? Integral. Why? Because like if I take x is equals to 0, force will be 10, x is equals to 1, force will be 10.5. Like the force is changing. Since the displacement changes, force also changes. It is not a constant force. So, I can use the second formula, W is equals to integral x1 to x2 f dot dx. So, x is equals to 0 to 2 they have asked. What is the work done now?
0 to 2.
Yes, 0 to 2 meters. Twenty-one. Okay, let's solve now. So, W will be equals to integral 0 to 2 0.5 x plus 0 to 2 10. So, with respect to dx, with respect to dx. So, if I integrate x now, what I will get? X square by 2. So, 0.5 into x square by 2 from 0 to 2 plus 10 into integral of constant will be with respect to x will be x no. So, 0 to 2. So, 0.5 into, and this is 4 by 2 minus 0 by 2 plus 10 into 2 minus 0. So, 1 times and this 2 times, and this is 1 and plus 20, which is nothing but 21 Newton meter, or else 21 joules will say. So, SI unit of work is Newton meter we can say, or else joules. Done. So, the next question is, an object is displaced from a point A, that is 1 comma 2, from a point A, that is 1 comma 2 to B, that is 0 comma 1. 0 comma 1. By applying a force F is equals to xi cap plus 2yj cap. Yes, F is equals to xi cap plus 2yj cap. So, in previous problem we have discussed about a single variable, right, only x. Now, in this problem the two variables are there. How we can proceed now? No. So, this is x no, and this is y. So, x axis separately and y axis separately. So, if I see these points no, this is x1 comma y1 and this point is x2 comma y2. So w will be equals to integral x1 to x2 x I cap, right now, plus y1 to y2 2y j cap. Got it? So the points I have taken only for x, that is x1 and x2, and for y, y1 and y2. I have integrated separately. Now we will get the answer for this. So x in the sense, which one?
Now A has moved from position 1 to
Yes.
1 to 0.
1 to 0. Yes.
And in y axis it is moved from 2 to 1.
Yes.
So I can take
you can take only f is equals to x and f is equals to 2y. Separately also you can do the same thing only, no? Separately you have done and you have added it. Now we have separated and we have added like this. X1 is initial, no? X1 will be 1 and x2 will be 0, no? Got it? Got the answer? How much? 3.5 you got. So let's check now. So x, no. So if I integrate this one, x square by 2, and from x1 is 1 and this 0 plus, and this is 2, I will keep as it is, y square by 2 from 2 to 1. Right, no? So first 0 by 2 minus 1 by 2 plus 2 into, this is 1 by 2 minus 4 by 2. Which 2? I can't cancel, no. I should integrate it first and I can cancel after that. You can cancel, you can take, you have taken inside and you have cancelled it. Okay, that's also correct. You have taken inside, okay, and you have cancelled it. So both are same only. So minus 1 by 2 plus, and this is minus, okay, minus 3 by 2 into 2 means 6 I have taken. So denominators are same, no, I'll keep as it is. So which will be minus 7 by 2, which is minus 3.5. Minus 3.5 is the work done. So minus, it should come, that's it. Done? So next one is, write the topic, spring constant, spring constant. And spring force, and spring force. So the formula is W is equals to minus 1 by 2 kx square, minus 1 by 2 kx square. So where k is the spring constant, So this is work done formula. Now if I talk about a spring, no, if I apply a force like F is equals to 5 Newton, the displacement happened is x1, like it can be expansion or compression. Or if I apply the force F is equals to 10 Newton, displacement happened is x2. Okay, so F is directly proportional to x, no? F is directly proportional to x. So I can say that F is equals to kx. F is equals to kx. So how much ever force I am applying, that much ever the compression or expansion will takes place. So the spring force is nothing but F is equals to Kx. You can take that spring force. F is equals to Kx. Then next one is potential energy. Potential energy. So potential energy is nothing but the stored energy. So the formula is U is equals to mgh. U is equals to mgh. So for kinetic energy, the formula is half mv square. Half mv square. So we have discussed about the kinetic energy with respect to momentum also. So momentum formula is equals to mass into velocity. So when I talk about kinetic energy, it is half mv square. So if I multiply m and divide by m now, I will get 1 by 2 m square v square by m. So can I rewrite this one now? 1 by 2 mv the whole square by m. So what is mv? It is momentum. So kinetic energy will be equals to 1 by 2 p square by m. So this is the relation between momentum and the kinetic energy. You can take a note of that. So the next question is, can you read the question? So the next question is, a rope is used to lower vertically a block, a block of mass m, by a distance x, with a constant downward acceleration, g by 2. So what is the work done by the rope on the block? So here a rope is there and a block is there. So this block has been lowered with a distance x, like a vertical distance. Okay. So what are the things I need to get for work done? Force into displacement, that is x or s, I can say. So what about force now? Displacement they have given x. What about the force now?
Can you take this mass into m into g?
M into g, but the rope also is there, no?
Then we get m into g minus t.
Yes. So one thing is, if I talk about the point mass, this is mg and this will be my tension. In which direction the rope is moving now?
Downward.
Towards downward. So this is my direction. So mg minus t, like which direction acceleration is there, that force I should take positive, opposite direction force should be negative, should be equals to, this is one weight and this is other weight, should be equals to mass into acceleration. How much they have given? G by 2. So G by 2. So can I get the tension? That's the force now here. Yes, no? That's the force. So can I write Fx cos theta? So the tension is acting upward and the displacement is going downward. The angle between them is 180 degree. So cos 180 is minus 1. Okay. So mg minus mg by 2 will be equals to t. So t will be mg by 2. So, I will substitute here. So, mg by 2 into x into
Now T is the force.
T is the force, because the rope is the holding, no, like this is the block and block is holded by the rope. Because of the rope only, like I'm slowly leaving the rope, because of the rope only it's going down, no. See, if this is the mass block and this is the rope, no, if I leave the rope only, the block is going down. Yes, no. For example, if I talk here, no, this is my pulley and this is the block M and one more block M is there. So, tension will be there. If this block is having less weight, no, this block will automatically go down. Okay, we are considering only this part. Got it? So, what will be the answer? So, no, everything should be in terms of mass, gravity and displacement, mg x only. So, I will read out the options. Options are mgx of mg x square minus of mgx and mg x square. So, minus of mg x is the answer. Suppose the question is given, the rope is going upward. So, what will be the answer? Yes, the displacement happened is same x only.
That T, if I take T minus mg.
T minus mg
Is
will be equals to mg by 2 right now, and T will be equals to mg by 2 plus mg will be nothing but 3 mg by 2. So, 3 mg by 2 into x into cos 180.
0.
Both are in the same direction, angle will be nothing but 0 degree. So, answer will be 3 mg x by 2. 3 mg x by 2. Done. Okay, write down next topic, work energy theorem. Work energy theorem. So, the formula is W is equals to change in kinetic energy, So, kinetic energy final minus kinetic energy initial. So, suppose if I consider a vehicle, it is going with some velocity u, and after some time the velocity has been changed to v. So, velocity has been changed now, obviously there will be some work done. So, the change in kinetic energy will be equals to the work done. And one more thing, like another work done formula is there, work done will be equals to minus change in potential energy. Work done is equals to minus change in potential energy. So, minus change in potential energy means minus of uf minus ui, which is nothing but ui minus uf. Potential energy initial minus potential energy final. Done? Okay. So, these are the previous year questions. So, a car moving at a constant speed of 36 km per hour in the direction of wind and assisted by the flow of wind, which imparts a force of 50 Newton. The frictional force between the tire and the road is 100 Newton the engine power required is. So let me explain before one topic, that is power. So power is nothing but work done per unit time. Okay. So the SI unit is watt. So this is one formula for power, and other formula for power is power is equals to force into velocity. Force into velocity. So two formulas for power, one is work done by time or force into velocity. So I can use this work done as kinetic energy also or potential energy also. Kinetic energy also, potential energy also. So work done is nothing but it's equal to energy only, no? So energy is nothing but capacity to do work. Okay. So can you give answer for this question now? A car is moving at a constant speed. So initially they have given speed as 36 km/h, like they have given the velocity, and in the direction of wind assisted by the flow, like wind assisted by the flow, which imparts a force of 15 Newton. Wind. Okay. And frictional force between the tire and the road is 100 Newton. So one force they have given, that is by the wind, and other force is nothing but frictional force, and one more force is there. What is that? No, by the car only. Yes, no, total three things are there. Two things are going in the same direction, one is opposing direction. Can you give answer now for this?
So can you take
F into
V?
try and give, we'll see.
So now three forces are acting.
Yes, obviously three forces will be there.
One is the cars.
One is cars.
Kinetic energy. Another one is the friction on the road.
Yes.
And the
Other one is the wind, assisted by the wind.
just I can write kinetic energy is into mass. What is the mass given?
Speed they have given. Speed, okay, this one I need to change into SI unit. 36 into 5 by 18 meter per second. So this is 1 times and this is 2 times. So 10 meter per second. That one I will leave as it is. This is about speed. Now can I say that force of the engine, that is car, plus force of the wind will be equals to, yes, no, will be equals to force of the friction. Yes, no, this car and this is wind and this is opposing direction, no?
If they are equal means, see, if the power that is coming from the car, the wind it is pushing it, if the friction is equal to that means the car will stop, no?
The thing is, car moving at a constant speed only, no? It's not raising or it's not decelerates, no? It is maintaining it. Yes or no? If it want to maintain, it need to be like in the same force only. Like what is the thing of Newton's first law? Object will be in rest or it will be in motion until and unless an external force is acting on them. So there is no external force now. The whatever force they have given, I have equated it. Okay. So which means
So then if it wants to maintain constant speed of
yes.
the engine and the wind must be greater than that of friction.
Which one?
The engine and
If it is greater, it will go in high speed, no? It will oppose the friction and it will go, no?
okay.
If it is less than, the friction will oppose and I will stop.
Okay.
It should maintain.
Maintain
In the sense, obviously it should be equal.
Okay.
Yes, no? So I don't know about the force of the engine now. I know about the force of the wind. What is that? 50. And what is about this friction? 100. So this is plus Fe. So Fe nothing but 50 Newton. So what is the thing they have asked? A car only moving with 36 km/h, no? And what is the power generated by car only they are asking. So can I say power is equals to force into velocity. And what is the force? That is 50 Newton. So 50 into the velocity is 10. So answer is 500 watt. Done. So the next question. Okay. I'll give that as homework now. So a ball of mass 100 gram is thrown vertically upward with a velocity of 10 meter per second from a top of a building 10 meter height. The kinetic energy of a ball as it hits the ground with the acceleration 10 meter per second square.
So I'll equate the potential energy at the highest to the kinetic energy.
Okay. Okay.
So if 10 grams.
I'll give a hint, wait. So initially the ball was there, some energy will be there, some E energy will take. After going to height h also, the E energy only will be there. After reaching the midpoint also, the E energy will be there. But the E energy can be converted to kinetic energy also, it can be converted to potential energy also, right now. So at maximum height, what is the maximum height given? 10 meter. 10 meter height, no? And what is the velocity they have given? 10 meter per second. So I can find the kinetic energy also and I can find the potential energy also. After hitting the ground, what is the thing they are asking, no? Ball has been, so ball of 100 gram is thrown vertically upward with velocity. It has been thrown from a top of a building, 10 meter height. Okay. A kinetic energy of a ball as it's the ground. So when I am throwing means like in the height I am standing, okay, I am throwing like this. So vertically height in the sense I have thrown, again it will go reach down only, no. So obviously kinetic energy will be there and potential energy will be there, but after hitting the ground what energy will be there?
Kinetic energy.
Only kinetic energy, because potential energy means mgh, h will be 0. Can I say if I get this answer will be equal to this one? So what is the answer? Half mv square, no? Half mv square plus mgh. Mass also they have given, and I should convert everything into SI unit. That is the main thing. 100 gram in the sense 0.1 kg, no? $15. Okay, that's fine. So half into mass is 0.1 and it is 10 square plus again 0.1 into 10 into 10. So this is 1 by 2 into 0.1 into 100 plus this is 10. Yes, no? I can neglect this one. So, and this is 50. Right? So 50 into 0.15 plus 10, which is nothing but 15 joules is the answer. Okay. So the next question. A neutron collided head on with the helium atom at rest. Collision is elastic and helium atom recoil with a speed of 2 into 10 power 5 meter per second. The initial speed of the neutron is. So momentum will be mass into velocity. So first object, this is like neutron n, and second object is helium. So this is having mass m1, initial velocity u1, mass m2, initial velocity u2. After colliding, again the momentum will be conserved, which means m1 v1, m2 v2 will be there. So can I say the equation m1 u1 plus m2 u2 will be equals to m1 v1 plus m2 v2. So similar, this is about potential energy, momentum. Kinetic energy is of m1 u1 square plus of m2 u2 square will be equals to of m1 v1 square plus of m2 v2 square. So two formulas are there. Can you give answer now? Initially, like I need to find what is u1. u2 is at rest.
Okay.
So collision is elastic. And the helium atom recoil in the sense return bounce with 2 into 10 power 5 meter per second. The initial speed of neutron is.
Then v1 will be 0.
u2 will be 0.
V2 will be 0. U2 is 0 for helium atom.
Yes.
Collision.
Yes.
After collision, if it is elastic means.
And the thing is, what is the thing like neutron and helium relation?
Neutron.
And helium.
They are the same. Mass is same.
No. Once you check it.
Helium has one proton, one neutron.
Neutron and helium. So neutron, if it is m, no, helium will be 4 times.
Correct.
Yes, no. So we got the relation for m and m1 and m2. Okay. So neutron is m. Okay, let me write here. Neutron is m and helium is 4m. Write the relation now. You can use this in both the equations now.
Plus m1 u2 is 0.
m1 u1 mu plus 4m 0 will be equals to m v1 4m v2. I don't know about v1, no, like they have given helium will be re-elastic with rebounds with 2 into 10 power 5. So can I say like this, m into u will be equals to m into v1 plus 4m into v2. Okay, I'll keep this relation as it is. So m will get cancelled. U will be equals to v1 plus v2. So 4v2. So v1 will be equals to u minus 4v2. Can I write?
Okay.
I don't know v2. So v1. I can use u and v2. I know v2. Now I can use this relation also now. Again, 1 by 2 I can take commonly outside, I can cancel it out. So this is equation 1 I will keep. So m u1 square, no, m u1 square will be equals to m v1 square plus 4m v2 square. M will get cancelled again. u1 square will be equals to, what is v1? u minus 4v2 square, v2, only v2 the whole square plus 4v2 square. Now you can expand this, and I need about what is u only, that is u1. So v2 I know. What is v2? 2 into 10 power 5. If I substitute the value, can I get u? Get the answer now. You got the points, no? So mu1 plus m2 into 0 will be equals to m v1 plus 4m v2. M get cancelled, u1 will be equals to v1 plus 4v2. So v1 will be equals to u1 minus 4v2. I will keep this one. M1, that is m u1 square plus m into 0 will be equals to m into v1 square plus 4m into v2 square. M will get cancelled off. u1 square will be equals to v1 square plus 4v2 square, and u1 square will be equals to v1 is u1 minus 4v2 the whole square plus 4v2 square. So a minus b the whole square is nothing but a square plus b square minus 2ab. So u1 square will be equals to u1 square, again this is minus, again b square, no, minus means plus 16v2 square, no, yes, no, 16v2 square minus 2 times of u1 and 4v2, yes, no, correct, na, plus 4v2 square. So u1 square will get cancelled off, and can I take this value this side now? 2u1 into 4v2 will be equals to 20v2 square, and 1v1 and 1v2 and v2 will get cancelled off, and this is 8u1 will be equals to 8 only, no, 20v2. So what is v2? 2 into 10 power 5, no. So 8 into u1 will be equals to 20 into 5 into 10 power 5. So u1 will be equals to, this is for how much? 100, 100 divided by 8 into 10 power 5 meter per second. Can you calculate this one? How much it will come? 12 point. So this is 4 times, and this is 50 times, this is 2 times, and this is 25. So 12.5 into 10 power 5 meter per second. This is my answer. You can take down. Done. So this is homework question. So this is homework question for you. So if the work done by a human heart is 0.5 joules per beat with the time period t of 0.8 seconds for a beat, no, the approximate energy required by a human heart to beat in a day is. So this is homework question. You can give answer in the comment boxes who are watching, and you can give answers in the next class. Okay.
Sir, see the human heart.
Okay. Thank you, guys. Tell me now.